Consider the following bank account class. So we have a balance right here, and suppose that this is a type of bank account where we just don't want the balance to be negative no matter what. And we have a constructor right here. For example, we cannot set the balance to a negative number. It'll be 0 then. And for example, the deposit, we can never deposit a negative amount, and then the withdrawal, we cannot withdraw a negative amount, and we can also not withdraw an amount that's more than the balance. All of this is to make sure that the balance is not negative, because having a negative balance is bad. Now let's say we have a bank account right here, and I put some amount of balance into the bank account. However, there's still one problem, which is that I can still do something like b1.balance equals negative 4.7 or something that's negative, which is not what we want. We want the balance to never be negative. However, the problem is outside of the bank account class, we can make our balance negative just by using an assignment statement. Now, that is not good because in the real world, having a negative balance can cause problems. So therefore, we don't want this. So how do we prevent client programs or classes that use the bank account class from modifying this by accident, basically? Because I can by accident like take away $10 when I only have $5. That's also bad. Well, it turns out in Java, there's something called an access modifier that can help prevent that. So first, the one we want so far is private, which means that only the class itself can access the variable. So for example, right here, this balance, we want to make it private because if we don't make it private, then this would be valid, and that's not good. And now that balance is a private variable, we have that we cannot do b1.balance equals negative 4.79. That is illegal in Java now, which is actually what we want. However, there's another problem, which is that we can't do stuff like print b1.balance, which is also a problem because we can't even access b1.balance actually. And a lot of times you might want to know what's inside of your account. So how do we do with that? Turns out you can make a get method. So for example, a public double get balance. So this is a get method or an accessor method. And basically what this does, I can just return balance. And now there's a way to access balance. So I can do, for example, print b1.getBalance as a method. Now, what is the advantage to having a get method and a private variable? Well, the reason we have this is because now you cannot modify the balance variable because you can't even access it. However, you can get the balance variable through the getBalance method. One important thing to note is that you cannot modify the balance variable through the getBalance method because double is passed by value, so I just return the value. It's not the same thing as this balance. So b1.getBalance, it's not going to get, if I set it to a variable and modify that variable, balance is still not going to be modified. So therefore, now we have a variable that we can access but not modify, which is good because in a bank account, you should want to be able to get the balance, but you shouldn't want a negative balance or something that can change your balance for no reason. One more thing to note about private variables is that they cannot be accessed in a subclass. So for example, special account extends bank account. So if I try to do, for example, balance, which is inherited from the bank account, and then equals 9, that will not work. Balance has private access. Similarly, I can't do stuff like super.balance or stuff like that. That's not allowed. One special case is when you redefine the balance like that. So now when I print balance, it appears to be changed if I create a new special account. So if I create it with 6, over here it appears to be changed to 9. However, this has some problems. For example, if I instead print get balance, it'll still be 6. And the reason is that special account basically inherits the get balance method, which means that it's going to return this private balance variable, not our redefined balance variable. Of course, I could overwrite get balance, but that's beside the point. Basically, the point is, for example, even if I do like get balance here, it's going to be 6. If I print balance here, it's going to be 9. Now, in Java, that is allowed. However, this is an extremely bad practice. So basically, in other words, don't redefine variables in a subclass, because that won't overwrite the variable. That'll just create another variable that's confusing with the same name. You can only overwrite methods. You cannot overwrite variables. Now back to the access modifiers. There's 4 different access modifiers. The first one we went over is private, which is only the class itself can access the variable. So basically subclasses cannot even access the variable. Obviously our public class right here cannot access the variable. Notice that in the bank account class, however, I can access the variable even in a static method. So for example, that is allowed because balance is inside the bank account. So even though it's private, we can access it inside the method, even though this method is static. Now, the other 3 access modifiers are default, protected, and public. So first we'll go over public. Public variables can be accessed by every class. So in other words, if I have a class A, public int A, like that, we're allowed to do that, basically. Because it's public, it can be accessed by every class. And as a matter of fact, this thing can be accessed by classes like external. Like, if we convert this thing into a package somehow and import the package to somewhere else, they'd still be able to do that. So basically, even if this was part of the Java library, they would be able to access public variables. Now, what are default variables? Well, default variables are like variables like int b, like that, and basically can be accessed by classes in the same package or project. So basically what this means is basically I'm still able to access the b variable inside of our main method right here. And the reason is that this public class is in the same package as A. Similarly, even if I make a new class, that is allowed because they're in the same project right here. Where it is not allowed is if I were to like package this into some place and then afterward try to access it from outside the package. Protected can be accessed by classes in the same package and also subclasses. So basically all subclasses can access protected variables even if they're not in the same package, but if they're in the same package, it doesn't matter. So for example, I'm allowed to do that. Notice that the only variable where I'm not allowed to access in the same package is private variables. So for example, this private variable I cannot access even in the same package. Every other variable, no matter what the access mode, I can access in the same package. In general, here's the practice. Usually, you should make variables private and potentially make get methods for those that need to be accessed. And default and protected basically can be used if subclasses, so protected can be used if subclasses really need it, and default can be used if other classes in the same project or package need it. Sometimes, in addition to get methods, you may want set methods or mutator methods. In the bank account class, the get method would be get balance, and then the set methods would be deposit and withdraw, because they modify the balance. In this example, this is good because the deposit and withdraw make some restrictions justifying the reason that balance has to be private. Here's another example. Class information with, say, private string info, like that, and then public information info equals I. Or say if I is not equal to null, then info is I. Then otherwise, info is, say, the empty string. Basically, the purpose of this time, what we want is that info should not be null. I'd never want info to be null because then there could be problems when accessing it. It could crash the program, which is really not good. So we want to do everything in our power to make info not null. So for example, the constructor, if I is not equal to null, info equals I, otherwise info is the empty string, just to make sure info is not null. And notice that we also made info private so that we can't modify it to be null. Now, for example, get methods, public string get info, return info. That's no problem because we cannot modify this info just by returning it. String is immutable. It has no like instance variables that are like modifiable from the outside. And now let's say we have a set method. And now if s is null, then I don't do anything because that's bad. I don't want it to be null. Otherwise, info equals s. Just say that. Now, what's the benefit of having a private variable and then a get and set method how is that different from having it be public? Well, here's one key difference. With a private variable, I can put restrictions on the get and set methods. In this example, I put a restriction on the set method, where if the string is null, I don't want to change the variable because otherwise that could potentially crash the program in the future. So this is an example where you may want get and set methods but still want the thing to be private. Here's another example of restrictions. Class secure information. So private string secure info. And then public secure information. And say string S and string password. So string P. And we have a private string password as well. Just say we have this. So secure info equals S. Okay, actually, to prevent crashing, if S is not equal to null, secure info equals S, else secure info equals empty string. Like that. And now, for example, the same thing, if P is not equal to null, password equals P, else password equals the empty string. So now I have my secure information. Of course, I must be able to get and set them. Now, this is where the private comes into play. Now I can make it so that the information is actually secure by making the people provide the password before they can get the secure info. Because they cannot access the secure info and the password without the method. So basically public string get info string password, or P, let's just say, if password dot equals P, then return secure info, else I return the empty string or null, whatever, just to signify the password is, incorrect. Perhaps in this case I might want to return null because there is going to be a problem. So now they can't get the info without the password. And of course they can't get the password no matter what. Now for the set method, again, string S, string P, if password dot equals P, then I can do something like, for example, if S is not equal to null, secure info equals S. Something like that. And now, when I have a secure information right here, if I provide the right password, then it'll give me my information. However, if I provide the wrong password, then it'll give me null, just as we want. Similarly, S1, now s.setInfo, QWERTY, and if we give a wrong password, then it will not set the info. However, if we give the right password, which is this thing, then all of a sudden it's changed to QWERTY. One last thing is that in addition to variables, methods can also be public and private in other access modes. So Basically, for methods, most methods should be public since methods are meant to be used. Some methods can be private if they are, say, helper methods that should not be accessed. So for example, let's just say our random class we can have a public void x that say prints QWERTY and then calls y, and then we have a public private void y that say does stuff. This is just an example. And basically now, without x, you cannot do y outside of this class. So new this thing dot y is not allowed. You cannot do y without x. Basically, that's what private methods are for.